everyone, in this video we're going to start exploring the decision rule and the critical value. Keep in mind, all the video we watched together so far, we are learning the process of doing hypothesis testing. So therefore, if you skip the previous video, you have to watch it before getting to here. Okay, so now this is the next steps. Let me go back for the decision rule. Let me show you back to the very beginning about our decisions. So we already learned null and alternative hypothesis, and now we're going to looking at our decision rule. And then so for the decision rule, let me go down here. So a statistical hypothesis is a statement about the value of a population parameter that we are interested in. For example, the parameter could be a mean, a portion, or the variance. So for this class, we focus on the mean because that's the most probably used in the business world as well. So a hypothesis test is the decision between two competing, mutually exclusive, and a collective exhaustive hypothesis about the value of the parameters, HO versus H1. So we are testing out, should we reject HO to take H1, or we cannot reject HO. Okay, so null hypothesis state a benchmark value. We also call it status quote. So therefore, when we set up the hypothesis testing, we are using, when we list the parameter we try to test, and we usually put the subscript 0 there to denoting, hey, this is my benchmark, my status quote's value we are trying to test out. So the hypothesized value, mu0, basically is testing the mean, or pi0 if you're looking for the proportional. Like I said, our class focusing on the mean itself. Once you know how to test the mean, the proportion tests are pretty straightforward. So they does not come from a sample, but is based on the past performance, an industry standard, a target, or a product specifications. So that came from your idea. You have some kind of thoughts, and you build up this hypothesis, the hypothesis value. Okay, where do we get mu0, the mean, the benchmark value? For example, the value of the mu0 that we are testing is a benchmark based on the past experience, an industry standard, a target, or a product specification. So the value mu0 does not come from a sample. Okay, because later on we're going to use the sample to structure the statistic to test my population. Again, I want to recognize about you if you feel confused at this point, because statistic is kind of abstract, because our goal always about population, but somehow we don't know population. But we need to state out, hey, you know what? We need to let everybody know we want to know population. And then, so therefore, we go to get a sample. Based on the sample, we're creating inference to allow us to understand the population. So I think a lot of confusion when students learning this part is, why sample? Why population? Why population? Sample, we jump around, right? I think the rule of thumb here is, okay, so we always want to know, our ultimate goal always just about population. Yes. Always want to go population. Since population information is unknown, what we did is we creating a sample, and we based on the sample getting statistic, and then to do the hypothesis testing to see, hey, is what we see in the sample can be representing the population. Okay, have that mindset. Okay, starting from population, that's our ultimate goal, and then we end up work on the sample because that's available data we have. Okay, so here, the key takeaway here is when we formulate our hypothesis, your HO and H alternative, they're all about population. Unfortunately, we don't know the exact truth about population, but based on the past experience, we are able to make a guess about our population, how they look like. And then how do we know our guess is right? So then we form the hypothesis based on the sample data, we form the statistic to test out our thoughts. Okay. So here we are introducing one tail and a two tail test, because this is a very important step to allow us to figure out what is the decision rule and the critical value. So for mean, the null hypothesis HO stated the value of the mu0 that we will try to reject. There are three possible alternatives. Again, I want you to focus on, as you've seen here, pay attention on H1. Okay, and also HO. So the left tail test. Okay, so first of all, the mu itself is representing the population. It's just a symbol. Hey, this is population. And that mu0 is that actual value we try to test. Okay, but that value is somehow we get it from our thoughts, historical performance, etc. So the notation here is a little bit confusing, but I want you to focus on what I'm saying. So the mu is just a notation say, hey, we are testing the population mean. And so for instance, the left tail test here, the HO is the population mean should be larger and equal to mu 0. So when you work on the practice questions, when you work on the homework, this mu 0 will give you an actual value. So let's say that mu 0 will be 2 or 3 or 4 or 2.3, depends on the question, right? And then the H1 will be the complement event, right? So since the mu 0 is mu larger and equal to mu 0, and then the complement event will be anything on the opposite side, right? So it's mu smaller than mu 0. Okay, so we call this, the first group here as left-tailed test. And so I know I'm going to show you a diagram later, but I also want to introduce that here already. Just thinking about our normal distribution. Let's see, this is a mu 0. As you can see here, mu smaller than mu 0, okay, it is located, when you think about smaller than, right, it has to be on the left-hand side of your distribution. So therefore, we call the left tail test because we are focusing on the left tail of your normal distribution. Okay, so basically, how do you know it's left tail or right tail? It is focusing on your H alternative, H1. Because H1, that smaller sign, this smaller sign is telling you that is left tail. When that sign is plus sign on your H2 alternative, we call it right tail because what we're going to testing, later I'm going to show you the graph as well, is anything, this is my mu 0. We are testing this side. Okay, so we call it right tail because on the right. And then, so when the H alternative is mu not equal to mu 0, and we call it two-tailed test, because later we're going to see the diagram is you're going to see like this. So this is going to be the half of the mu 0, and this is going to be half of the mu 0, and then we're testing both sides. Okay, so that is one key takeaway from this slide is that in order to know whether it's a right tail test, left tail test, or two tail test, you're going to go to look at your H alternative. So if your H alternative is mu smaller than, that is left tail. If it's mu larger than, that is right tail. If it's mu not equal to, that is two tail test. Okay, so as you learn so many math does involve some kind of memorization. Hope this lecture help you to have understanding it and then remember it. Okay, so that's one. The second is about your HO. Okay, did you notice that regardless what kind of test you're facing, left tail, two tail, right tail, that equal sign always showing my HO. Okay, this is very important. So when you do any hypothesis testing, that equal sign should always show in your HO. If it's not there, you are making a mistake. So think about why, right? HO is about our status quo. We know for sure it's happening, right? So if you know for sure it's happening, so that equal sign has to be there. So therefore, don't forget when you set up your hypothesis testing, that HO always has to have that equal sign. Now, the reason I emphasize it because you have homework assignment on the Connect. As you're working on it, they're going to, hey, give you this case. Can you help me to figure out HO and HO1? So the key here is you pretty much can eliminate a few. If you notice your HO had no equal sign, you know that's going to be the one not selected. And then the next step going to be looking at, hey, am I looking at left tail test or right tail test or two tail test? And then to determine, should I use a smaller than, should I use larger than, or should I use not equal to? Okay, now first you know how to set up your hypothesis. Let's look at your rejection, your rejection rules. Before we move on that, so let's look at example together. So EPA guideline for the maximum safety level of the random. So it's kind of very naturally occurring radioactive gas is very poison. In the home is 4.0 picoseries per liter of air. Sorry for my pronunciation here, not too familiar with this measurement. So when the home is tested, a number of the measurements are taken and averaged. So basically we're testing the average. A homeowner would be concerned if the average radon level is too high. In this case, the homeowner would choose a right tail test. Think about why, right? If the thing is too high, we're going to take action. We need to move out of the house or do something with the house, right? So the inequality in HO1 indicate the tail of the test. Okay, again, some students are going to say, why the status quo is not our home have radon? Again, if that's the case, the house already been rebuilt, right? Because the status quo is we assume all the house not have that overloaded this kind of chemical. So therefore the house still there. Like I said, otherwise the house already be gone, right? So therefore the status quo is the mu smaller and equal to 4.0. You can see what I said about mu 0 P4, right? That mu 0 always going to be replaced by actual number you're going to see in the question. So we assume HO is true unless evidence says otherwise. Okay, since the homeowner is worrying about if there's higher than 4, they need to do something with the house. Therefore, they are doing, what they try to figure out is if the mu actually going to be larger than 4. If that's the case, they need to do something with their house, right? So therefore, we call this as right tail test because my H1 is mu larger than 4.0, okay? So you will have more practice question in your homework assignments. Make sure you practice what I just said. Hey, what do you care about to know? The one you care about to know will be your H1, and the status quo will be your H non. Okay, so the mean random level is assumed safe unless the sample mean indicate an average random level too far above 4.0 to be due to chance variation. Okay, so now you know how to set up the hypothesis. Now let's look at the decision rule. I already introduced in the 3 chart already in my first couple minutes, right? So we rely on our knowledge of the sample distribution and the standard error of the estimate. That is what we covered in the last chapter. So the area under the sample distribution curve that define an extreme outcome is called a rejection region. Okay, so think about the sample distribution. Everything we're focusing on is within this threshold, right? Now we're looking at the area outside that threshold. So you can see the shaded area. So we may visualize the level of significance alpha as an area in the tail of the distribution. For example, the normal far enough from the center that is represent an unlikely outcome if our non-hypothesis is true. So that's just put it simple. When we think about the left tail test, and so the alpha we set up that is trying to control the type 1 error, the probably we are rejecting, but when non actually is true, right? So the alpha, when we do the left tail test, that alpha is equivalent to this shaded area. So now you know why we call it left tail, right? This shaded rejection area is on the left hand side of the tail. So this left hand side tail is actually capturing my H1. Okay, if you think about the left tail, right, like this one, this one, left tail, like this one, left tail. So it will be mu smaller than, so anything smaller than mu 0, right? So it's a left tail. And then it's reflecting my H1, right? So mu smaller than. When we look at the two-tail test, it's mu not equal to, right? So if mu not equal to, it will be outside that critical value. So therefore, half of them is on the right-hand side and half of them are going to be on the right-hand side. So half the alpha on the right-hand side, half the alpha on the left and the right-hand side. So when we look at the right tail test, again, focusing on H1. So in that scenario, we're testing mu larger than mu 0. Okay, our rejection region is on the right-hand side, right? Right-hand side of that tail. So this area we are shaded here is the alpha. Okay, now at this point, you want to thinking is, okay, so now it's very clear if we are doing the left tail test, we are creating that statistic to see will they end up located at this region. If that's the case, we have to reject, right? If for the two-tailed test, which we were focusing on, if the statistic we are creating is located at these two rejection area, if that's the case, we will reject HO. For the right-tailed test, we're going to look at, after creating that statistic, to look at the values to see if they're going to be located at the right-hand side of the tail. If that's the case, we will reject. Okay, so we will calculate statistic that measure the difference between the sample statistic and the hypothesized value. A test statistic that fall in the shaded region will cause rejection of the HO. The area of the non-rejection region, which is the white area, you can see all of those, right? So we consider as the non-rejection area. So that's area equal to 1 minus alpha. Okay, so now we're going to look at the critical value. So the critical value is the boundary between the two regions. And so basically, we're going to look at if the value we calculate, we will fall either larger than the critical value if it's a right tail test, or smaller than the critical value if the left tail test, or if it's a two tail test, then we're going to look at it if the critical value are within that two rejection area. Then we will decide whether to reject or not. So decision rules state what the critical value of the test statistic would have to be in order to reject HO at the chosen level, the statistic level. Okay, so that is the very theoretical part. Okay, so what we're going to walk into in our next video is, hey, you still try to digest this so many steps. Let's start putting action. Learn one of the tests. So then we can revisit this process. You will understand better. It is okay at this point, like there are so many things going on in my brain. I still don't know how to do the hypothesis testing. It's very common. But I think the key takeaway at this point you need to know is that first of all, you know how to set up HO and H1. And you know what is the left tail test, what is right tail test, and what is the two tail test. So in my next video, we're going to look at a specific case, and then you're going to be able to put all those things together to say, hey, you know what? I know how to do the hypothesis testing now. And then the last video we're going to look at will be, we will focus on the Excel skill to learn. Let's use the Excel to help us to calculate the statistic, help us to determine if we should reject HO or not. Okay, see you in next video.